Hello, I am Dr. N.V. Hulle from G.H. Raisoni Institute of Engineering and Technology, Pune, Maharashtra. And in this particular video, we will discuss about VLSI front-end design using VHDL. And to begin with the basic point, I will start the discussion with the two simple points, that is introduction and elements of the VHDL language. Under the introduction, we will discuss about what is the full form of the VHDL, how it can be used, what it consists of, and so on. And under the elements of the VHDL, we will discuss many more points, that is technical details of the VHDL language. To begin with, introduction. VHDL is digital system design using HDL, that is hardware description language, is established methodology in ED, that is electronic design automation. And this VHDL stands for, this V stands for VHSIC, means what? Very high speed integrated circuit. The second H stands for hardware, D stands for description, and L stands for the language. That is VHSIC, hardware description language, is the full form of the VHDL. Features of the VHDL, what it consists of. This VHDL is a strongly typed language and it is not the case sensitive. This capital letter has the same meaning as the small letter in this particular language. This language is the combination of concurrent language, sequential language. We can use the timing specification, we can use the simulation, we can test the circuit, we can create the design hierarchies, and it will support the design libraries. Means it facilitates the device independent design and portability. These are the basic points regarding VHDL. Apart from this, it is a concurrent language. Means what? The concurrent statements can execute at the same time in the parallel as in the hardware. Means in this case, this is some adder, this is another adder, and we are planning to add A, B and C, D. All these adders are working parallelly. Means these two adders are working parallelly. Whenever its output is available, it can be given to this, and this can be the statement which is used in the VHDL. Means it can be used as a concurrent language. At the same time, it can be used as a sequential language. Means what? It is a sequential language. This here, the statements are executed from left to right in the horizontal direction and top to bottom in the vertical direction, as in case of the any language. Sequential statements are executed one in time in the sequence, as in case of the conventional language, from the left to right and top to down. And sequence of the statement is important, because in case of the sequential language, the sequence of the statements has a lot of importance that is applicable to this VHDL also. Apart from this, I mentioned it is a timing specification language. Here in this case, timing is one of the concept which makes VHDL different from other programming language. Means definition of the signal attributes which provides the wealth of the timing and information about the signals and ports. Wait statement is explained because of its importance in providing the synchronization in the process. For example, this is process begin, clock is equal to 0, wait for 10 nanosecond, clock is equal to 1 and wait for 20 nanosecond, end process. Means in this case, we are able to generate the waveform which has clock is equal to 0 of 10 nanosecond and clock is equal to 1 which is of the 20 nanosecond, and the same is repeated again and again. Means this period is of the 10 nanosecond and this period will be of 20 nanosecond, and these periods can be defined by the user, and accordingly we can provide the inputs to the system, or maybe we can take the output from the system accordingly. This is simulation language. VHDL has many features appropriate to design the behavior of the electronic components, ranging from the simple logic gates to complete microprocessor and custom chips. The resulting VHDL simulation models can be used as a building block for the larger circuits. Means we can have a simulation of the AND gate, and then we can have a simulation. We can use AND gate and XOR gates combined together to have a design of the full adder, and full adder can make the other higher order kind of the things, and then that can be used as a internal components of the bigger models or bigger designs. Means here the building blocks can be used in the larger circuit. Means here this language can be used as a simulation language. The VHDL can also be used as a test language. Here VHDL test bench is the VHDL code that produces stimuli to test your design correctness, and it can automatically verify the accuracy of the VHDL code. Given known input, does the system to generate the expected output. Means we can give the known input and we can check the expected output. If output is incorrect, means there is some logical error is available in the program, and we can verify those things. Design hierarchy. Hierarchy can be represented in the VHDL. Consider the example of the full adder. Full adder is the top module. Here this is top module. This full adder is the top module, and it is composed of the three lower level modules. There is one is this half adder, this is second half adder, and this is the OR gate. And in this way, this full adder can be used as another internal module for the bigger system kind of the things. Logic system. Need for multi-valued logic system. Conventional logic system has only three values, that is 0, 1 and this Z. Z means high impedance. Now if we are considering the truth table, this is truth table of the AND gate 0, 0, 0, 0, 1, 0, 1, 0 and so on. For one input is 0 and other input is Z, that is high impedance, that is disconnected, or terminal is not connected. This B port is not connected. In that case, what the output we should expect from the device, which is quite impossible to define. In such cases, 9 values packages of the std_logic_1164 was developed and accepted as a IEEE standard 1164-1993. It is known as multi-valued logic. Means what? Here it has another logic levels or values. First is unknown. The value was known, but it is not anymore. Uninitialized. The value was never known in the first place. High impedance. Net has no driver. Drive strengths. Handle different output drivers. Don't care. Optimizes synthesis implementation. And these 9 logics can be explained something like this, which is the part of the package which is IEEE STD 1164-1993. U means logic U means uninitialized, X means unknown, this 0 means logic 0, 1 means logic 1, Z means high impedance, W means weak unknown, L means low 0 or weak 0, and H means low logic 1 or weak logic 1, and this hyphen means it is the don't care. These are the 9 possible inputs we can provide, and the system will provide these 9 possible combinations of the outputs, and these are the logic systems which is available in the VHDL in place of only 0 and 1. Other things are also available in the VHDL language. Now I will come to the elements of the VHDL programming. What are the elements it has? The basic building blocks, then entity, then architecture, then language elements, then concurrent statement, then sequential statements, then signals and variables, then configuration, and then operator overlaying, and many more. To begin with, basic building blocks of the VHDL programming, I will conclude this lecture. It consists of entity, The designer's interface to the external circuitry, just like inputs and output ports. Architecture, it describes design's behavior and its functionality. Means internal architecture of the system or internal architecture of the proposed system. Configuration, it binds an entity to the architecture where there are multiple architecture for the single entity. Any VHDL program should have only one entity, but it may have the multiple architectures. And whenever we have the multiple architectures, in that particular case, we can use the configuration. Packages contains the frequently used declarations, constants, functions, procedures, and user data types and components, and it can be called as and when required. These are the basic building blocks of the VHDL programming. Thank you. That's all.